We've now seen that the units that you measure your data in will have an effect on the variance and the standard deviation. And so if you change the units, you're going to change the value of those statistics. With standard deviation, the translation between units is really straightforward. If you had to take your data set and multiply everything by 12 so that you would convert from feet to inches, then your standard deviation would also need to be multiplied by 12. So it's fully proportional. If you had data on income in dollars and you wanted it in pennies for some reason, and so you multiplied all of your numbers by 100, then your standard deviation would also scale up proportionately by 100. With variance, that's not the case. It scales up by the square of the conversion factor, which is kind of weird. It's one reason why we like the standard deviation better. Now, I think this is still kind of vague, so I'd just like to show you in Excel what happens when we rescale our data. So let me pull up Excel and just show you a quick example. I've just keyed in some random numbers. Let's just say these are exam scores, and they're absolutely hideous. From these exam scores, we might want to calculate some nice summary statistics. Let's do that first, then change the value of our data by multiplying them by something, and then see how that affects our statistics. So for average, we just type average. It's B1 through B10 in my example. And so the average is a 50. Let's say these are horrible exam scores. The variance of B1 through B10, oops, the variance of B1 through B10, and the standard deviation of B1 through B10. Okay, so far so good. And now let's say as a professor, I'm like, man, this is really bad. Tell you what I'm going to do. I'm going to double everybody's score. All right, now, just real quick, what do you think is going to happen? I mean, your scores are going to go up. They're going to double. The average will also double. So rather than having an average of 50, you know it's going to be 100. We should see the standard deviation also doubling because that one scales up proportionately as well. So we should see something like 13.9. And then for variance, we're going to get something very, very weird. Okay, so let's rescale our data. So I wanted to recalculate something, and I want it in this cell to put 40, which is B1, times 2. And then I can just copy that formula all the way down. So my 50 becomes 100, my 44 becomes 88, 40 becomes 80, and so forth. And now let's take our formulas and highlight those, grab the little fill handle there, and copy over our formula. Okay, so we get exactly what we were expecting. We doubled our average from 50 to 100. We double our standard deviation. So if I could have multiplied properly in my head, we'd get 6.85 times 2 is 13.70. But what happens to the variance is just crazy. Now we multiplied all of our data by 2. 2 squared is 4. So really what we have to do for variance is take this original number and multiply it by 4 to get the 187. And let's just double check that that's what happened. So we want the value that was in B13, and then let's multiply by 4. We should get 187.56. And there it is with rounding. So if we get rid of our rounding, that's exactly what happens with the variance. Okay, so one last time. The average scales up proportionately. The standard deviation scales up proportionally. But since variance is the square of the standard deviation, when originally you were multiplying that standard deviation by a conversion factor, but that conversion factor gets squared. So the variance grows by the square of the proportionality factor, of the conversion factor. Okay, so now you've seen it in action.